Awesome. Welcome, everyone. I see the attendees number growing. It's good to have you all. My name is Olivia. I am the co-chair of the Climate Change Committee at Astrobites with Suchi. And this is our first Earth Week 2022. I see a lot of names that we've seen in the other events. So thank you for engaging with us and continuing to show up. Today we have a pretty exciting panel of people that are working in some respect in astrophysics sort of work, as well as climate advocacy. And we're going to be talking about the interface of those two things and how you can bring an astro/physics background to that climate work. So I'm going to start us off with sort of an introductory question. We will we'll try popcorn style, and if it goes well, we'll continue that way. So starting with introductions, talking about your career path, I invite the panelists to describe your career path, what brought you to climate work, and if you could describe your background in physics and astro and in climate work. Okay, I'm going to tag someone. Gabriele, would you like to start?
Sure. Yeah, so I'm Gabriele Betancourt-Martinez. My current position is a science program officer at the Heising-Simons Foundation, which is a philanthropic foundation based out in California. My background is in kind of astronomical instrumentation. So I mean, kind of going back to the beginning, I think as a kid, I always loved both being in nature and astronomy. Like with nature, I just loved land. I just had this really strong connection to land and like conservation, but at the same time, I loved, you know, the mystery and the wonder of astronomy. So that kind of became what I ended up focusing on academically. And I think if you look at my CV or resume, it looks like I've had this really straight and narrow path, but in reality, I know I've always had a lot of different interests, which means that kind of at many different points in my career, I've kind of looked into other things. So in grad school, I was in grad school for astronomy. I went to the University of Maryland, just outside of DC, and kind of halfway through, I had a few different, let's call them career crises, but as I was finishing up, I was really starting to feel this kind of pull towards like getting more directly involved with the climate crisis. And I started thinking really seriously about kind of pivoting into climate science, like doing just, you know, changing my science topic and doing climate science. And then I talked to a lot of people. I considered, you know, applying for postdocs in this. And then I thought, no, this is not quite it. So I thought about climate solutions, and since I have kind of like an instrument background, I thought, oh, I could apply, you know, my building skills to like cool technology out there that's just some sort of neat solution to the climate crisis. Long story short, for many reasons, I decided to pursue a postdoc in astronomy rather than making that pivot at that point. But during my postdoc, I discovered the group Astronomers for Planet Earth. And I think this was something that I was really looking for and needing, just kind of this community of like-minded people that I could learn from and work together with and like actually start to take action on some things. So, you know, that kind of helped, I think, focus my own thoughts and values. And so when I had about a year left of my postdoc, I really started doing a lot of soul searching to figure out what I wanted to do next. And I kind of felt like I was ready to leave research at that point. And I knew I wanted to do something. I didn't know what it looked like, but I knew it should involve astronomy. It should involve like the Earth somehow. And it also, like, I really wanted to work on kind of supporting and uplifting underrepresented folks in physics and astronomy. And out of nowhere, I found this job posting for the Heising-Simons Foundation. And philanthropy was never something I considered. I didn't really know much about it. But the science program at Heising-Simons encompasses astronomy, physics, climate science, increasing and the numbers and supporting women and underrepresented people in physics and astronomy. So it kind of brought all these different passions and interests of mine together. So that's how I ended up where I am now, but it's just been since January. So I'm still in the early days and still learning. Should I pass it to somebody?
Yeah, do you want to tag someone?
Sure, I'll tag David.
Okay, thank you. Good morning. I think my career path has been a little bit unusual. I'll try to keep this short. I ended up, first of all, going into space science for, I guess, almost cliche reasons, being inspired by the, when I was a little kid, by the Apollo moon landings and by the first planetary missions that were happening, when I was a teenager, the first landing on Mars and the first mission to the outer planets. It was like, this was exciting in the future. And, I wanted to be part of it. And I was also kind of a science fiction geek, and that all kind of mixed together with it, like space was the future. And it was also an aperture to a better, brighter future where humanity was going to be united and solve problems through enlightened application of science and a global view that came out of space exploration. So there was a sort of utopian view of the future where that space was mixed up in. So that's why I pursued a path to space science, and I did an undergraduate in planetary science, and I also got a degree in philosophy of science, which was kind of maybe unusual when I was an undergraduate, but I feel like that has sort of figured into my longer path, because I learned about ethics and environmental ethics and philosophy of science in different ways and things like that. And then I went to grad school, and I learned a lot about atmospheric evolution and climate modeling when I was in grad school, and my thesis was involved in that because I wanted to help figure out what was happening on other planets. But then part of that ended up being a project about climate evolution of the early Earth. And one of my mentors, one of my scientific mentors, was Carl Sagan, who was also the first person I ever heard talk publicly about the threat of global warming. And then it was interesting that he was using a lot of the same terminology and physics that I was using to try to do these more arcane problems to solve what was happening on other planets. But he was referencing these terms and these ideas that I was familiar with and was trained in, even though I hadn't trained to learn about Earth climate. And then just for a second, another parallel part of my biography, which, I didn't realize these were going to link up, was that I was kind of raised in an activist family, and my parents were very involved in like the nuclear disarmament movement. And my first political action, I was pushed in a stroller when I was 3 years old in a Ban the Bomb march in Boston. And then I got involved when I was in college. I got involved in a group, the Brown Disarmament Group. I was an undergraduate at Brown working on disarmament. And, the big fear about the future, the big existential threat was the nuclear arms race. And anyways, a little bit later on, when I was postdocing, and interesting, my postdoctor advisor, Jim Pollack, was one of the people that worked on the theory of nuclear winter, which was a really interesting application. They started thinking about dust storms on Mars, but ended up realizing, oh, this physics also applies to what happens when we load up Earth's atmosphere with smoke and dust from nuclear weapons. And it's the same problem, but here it is applied to Earth. So there were these connections that kept sort of appearing between what the theory for other planets and the theory for Earth. And I don't want to talk the whole time because I had a lot of different jobs, but I was a university professor. I was a museum curator for many years. And I wound up with a career that was I have wound up with a career that's been sort of half-time NASA supported research in planetary science and about half-time public outreach and other kinds of communication efforts. I've written a few books. I mentioned I was a museum curator. I've done planetarium shows. I've done various other communication projects. And I've ended up focusing a lot of that on sort of lessons about Earth climate that we can draw from what we've learned of studying climate on other planets, both specific things like, oh, there's some problem with our climate model that we didn't realize until we tried this weird thing on Venus, so we get better at doing Earth, but also the sort of, even maybe more importantly, the perspective that we validate that climate is a real thing that we really can model by trying it on all these other planets, and also the sort of deep space and deep time perspective on humans on Earth, which I ended up really being able to focus on. This is the last thing I'll mention. I applied for and got what seemed like a weird position. I was the first one in what is now a string of, there's a position at the Library of Congress called Curator of Astrobiology. And I urge any of you who might be interested to check it out, because it's very broad who can apply for this. Anybody that's interested in somehow applying astrobiology to wider human concerns. And of course, that includes climate change. And because I was selected as the first one, the inaugural chair of astrobiology, that gave me a year to work on basically whatever I wanted. And what I worked on, what ultimately became a book, applying astrobiology to sort of humans on Earth. What are we doing to this planet, and how does that fit into the story of Earth evolution? And that kind of deep space, deep time perspective allowed me to really explore that nexus between my science of really comparative climate of the planets and the terrestrial situation on Earth and how to think about our future. And I ended up, part of the book is, I think, really about eco-anxiety, although I didn't use that term because I hadn't heard it a few years ago. But I did talk about, what kind of perspective we can gain on ourselves by the long view, and how some of that is actually hopeful, where we see that humans over time have been a problem-solving species and adapted to changing circumstances with a kind of capacity for reinvention and reinventing our relationship with the natural world, which in a sense is really our larger challenge right now. Anyways, those are some things about me, which I'll stop because I want to hear what the rest of you have to say and get on with the conversation. So I will now popcorn below me on the screen to Kirsten.
Thank you, David. Yes, my name is Kirsten Hall. I am currently a Schmidt Science Fellow, which is a postdoctoral fellowship position at the Harvard and Smithsonian Center for Astrophysics. And I work with the atmospheric measurements group there currently. So my path through my career so far has been to go to college thinking I was going to be go into medicine or something like this. And I went to UNC Chapel Hill, where I took my first ever astronomy course, Astronomy 101. And I heard the first actually scientific lecture on climate change from my Astronomy 101 professor, Professor Dan Reichert. And that was phenomenal and really sparked something in me. But in addition to that, he's a phenomenal astronomy professor. So of course, that really is what ignited my passion for astronomy and physics. So I went on to, get a bachelor's degree in physics while taking as many sort of Earth-focused like geography courses as possible, but ultimately decided I wanted to go to grad school for astrophysics. And so I was spending a lot of time playing catch up as a sort of novice in physics in my second year of undergrad, taking it for the first time. And so that really got all of my attention and focus, I think. And so sort of fast forward after a few years of grad school, I was feeling that draw back towards my interest in earth science. And I'm an extragalactic astronomer. I study galaxy evolution over all of cosmic time, really, pretty much as far as away from Earth as you can get, including using the cosmic microwave background in a lot of my research. So I felt really disconnected and really wanted to get reconnected with the Earth and with human impacts and things like this. And so I heard about this really, really phenomenal program called the Schmidt Science Fellows. And what they do is they hire postdocs straight out of their PhD with the goal of discovering the next generation of science leaders that will transcend disciplines and solve the world's most pressing problems, with the idea that in order to do that, it requires interdisciplinarity. So it requires a intersection of diverse scientific minds and diverse human beings to come together and solve, really, really the biggest problems in the world, including like world hunger, climate change, et cetera. And wow, did that excite me, right? So I applied at the end of my PhD to make this scientific pivot into climate sciences, where I then had the opportunity to focus on, okay, where are my skills directly transferable into this new area of research, and ultimately I kind of landed on the area of atmospheric measurements, sort of taking those telescopes that are looking out in space, turning them around on Earth, taking images, things like that, spectroscopy, and joined the atmospheric measurements group at the CFA through this amazing opportunity of this fellowship, where then I kind of have, over the past year and a half or so, meandered my way into really a niche focus on like atmospheric dynamics. And that's what I've been up to. And actually in the fall, I'm going to transition back to an astronomy postdoc for a little while, also here at the Center for Astrophysics. And I'm just sort of kind of building my own career path as I go. So I think it's really amazing to be on this panel with people who seem to also just kind of be figuring it out in this intersection space. And yeah, that's the brief introduction to me. So I will pass it to Nora.
Hi. So I have a little bit of a different background. I'm a high school physics teacher in Boston, and I think I started thinking about climate change when I was a high schooler. When I was a high schooler, someone came and talked at school about climate change, and I decided that the thing I was going to do to help fight climate change was not learn how to drive, much to the chagrin of my parents. And I still don't know how to drive. And as someone who teaches high schoolers, I think really that is such a high schooler developmentally reaction to that. And I always really loved nature and cared about environmentalism, but didn't really know how to access climate work. And I went to college for engineering because I enjoyed the applied physics. I enjoyed my physics classes, and someone told me, here's how you can make it more applied and hands-on. And I ended up studying engineering at Smith. And then after, I very quickly realized I did not want to be an engineer. I wanted to be a teacher, which is what I had wanted to be before I decided junior year of high school I wanted to be an engineer. So yeah, I studied engineering, and after college, I did environmental education for 3 years, taking students out into the woods and kind of talking to them about environmental issues. And then I went back into school to become a high school physics teacher. I'm in my 10th year of teaching, and for a lot of that time, I've really cared about justice issues, including the climate, but that has not really been my focus. I focused a lot on immigration and policing, and felt a real disconnect between the justice work I've been doing around immigration and my physics classroom. That part of my identity couldn't come into the physics classroom, and I would look at my friend who was a history teacher who could talk about the history of immigration in her classroom and bring it into modern day. And this past summer, I did a workshop called Energy and Equity, and I really from that really realized that I could bring in climate issues and energy justice issues into my classroom. And so really this year have been working on, when we talk about, conservation of energy, when we talk about like basic electricity units, I also did an energy generation unit about how energy is generated, and also local environmental justice issues, and really bringing local issues in the Boston area into my classroom. And it has been really amazing experience to show my students that like physics doesn't just happen in isolation, that all of this is connected to the world that they're living in. So I'll leave it at that, and I'll pass it to Colin.
Hi there. So I'm Colin Hill. My current job, which I started about 5 weeks ago, is with a private company, a startup company called Regrow. And in general, they are working on transforming farming and the food supply chain, and through adoption of regenerative agriculture. And so my specific role is working as a kind of technical lead for the Sustainability Insights product. And this is like to help food companies, NGOs track the adoption of these regenerative practices, to calculate emissions reductions, and to kind of identify opportunities for sustainable partnerships. So how did I get there? So from a young age, I've always been interested in nature and, how does the universe work, those types of questions. So yeah, I was really interested in maths and physics and in high school. That took me to undergraduate physics degree, then PhD in astrophysics, followed by about 3.5 years of postdoc in observational astrophysics. So that was looking at magnetic fields of stars and planets, time series analysis of spectra. And towards, throughout this whole period, I've been interested in the environment and climate change, and kind of being aware of all these things. But really towards the last part of a postdoc, I felt like I wanted to work in this problem, like either the problems faced by people having to adapt to climate change, or to work on solutions, at the source. So I decided to step out of academia and go into the private sector. I wasn't sure exactly what I wanted to do and which sector to work, but I knew that I needed to have some type of experience, working with Earth observation data sets, and I was interested in that, so I pursued that. So then I worked at a startup company for a few years with weather forecasts and land surface modeling. And so that was mostly applied to agriculture. So I was doing kind of data scientist research development with them. And then, so that kind of, it was good because it was, you get to understand the context of all these things, like what is useful for the end user, and how can they, like, what are the impacts of, changes in temperature or rainfall for farmers specifically. And then, so after this 2 years of that company, I recently changed to this new position, which is a bit different and focuses more on the specific causes of greenhouse gas emission in the agriculture sector. So yeah, it's I'm still finding my way, and learning the different pieces that go together to make up this. It's a whole different, the business world is very different from academia, and there are pros and cons to that, but it's been an interesting journey so far.
Yeah, well, thank you to all of our panelists for their very thoughtful answers here. Moving on a bit, now that we've heard about everybody's backgrounds, we'd like to know how the panelists actually leverage their physics backgrounds in their current work, and also in the context of having these very technical astrophysical education and work experiences. Where do you think our efforts and energy should be directed in climate work and future efforts? So again, I think we're just going to call on people and popcorn like that as well. So Kirsten, maybe you could start.
Yeah, absolutely. So this is such a good question because there's so many areas. There's so much actionable action items that can be approached. So, you know, if it's in the sense of you are a physicist or astronomer that wants to, you know, pivot your career field entirely, but you still want to do science, you know, there are just a myriad of possibilities because, you know, the training that you've had so far as a physicist is just going to be directly applicable to many different areas of material science in the climate space, or something like what I did, atmospheric dynamics, or even just like going all the way into field work or something that you couldn't even imagine. So whenever I was making the pivot, I really wanted to sit down and think, okay, how can I directly take this skill and transfer it to this skill, right? Like I'm really used to analyzing big data sets and maps and things like this. So let me take all my, you know, programming and statistical skills and just directly transfer it over. But now that I've been doing this for some time, I realized that I think I could have done anything. I think I could have gone into ocean acidification or carbon capture if I really wanted, because I think all it really takes is the drive and the interest, right? So that's my answer on the scientific front. But on the like solutions front, right? Like if you just want to start making changes in your own life, there's so many other options about how you live or how you vote or who you talk to or what kind of community activities you're involved in, and that just is applicable to anyone. So I guess that would be my brief answer, and I'll pivot down to David for his response.
David,
Unmute. There I go. I have no mouth, but I must scream. No, here I am. It's a great question, and when I see the question of, you know, how do I use climate knowledge in my work, I think that, you know, that my work is really sort of roughly divided in half between my actual scientific research and a lot of effort I put into various kinds of communication and teaching and outreach. And so I guess I have a slightly different answer for each of those. As far as the research, you know, there are a lot of interesting connections between what we know about our growing knowledge about the climates of other planets and our growing ability to understand climate change on our planet. And I actually helped start a series of conferences on comparative climatology, and there's been at least one book that's come out of that now. And these are really interesting conversations because you get people that are interested in planetary climate together with people that are interested primarily in Earth climate, and a lot of people who've sort of spanned both. And you know, you realize that there's a lot to learn going both ways. You know, just for example, one of the biggest unknowns still in climate models of Earth, as far as our ability to project the future and how different forcings are going to affect things, is the role of clouds. Clouds are really hard to model, and the forcing can go either way. And that turns out to be, you know, a big problem also in modeling other planets, and in particular Venus, which is a planet that I've worked on a lot. And I think the knowledge goes both ways, that when we learn things about how to do a better job modeling clouds on Venus, it can feed back and help our models on Earth. And there's a couple other examples, and, you know, they may seem like persnickety things, sort of tweaking our models a little bit, but we've learned a few little things about how to model even carbon dioxide. It's spectral shape. There's something called the far wings of the carbon dioxide bands, which you don't typically worry about on Earth, but you worry about where you have an atmosphere that's 100 times as dense as Earth's atmosphere, and mostly CO2, these subtle effects that start happening. And then you say, well, we fixed this on our Venus climate models. And can that help us with our Earth models? Well, a little bit, so you find these incremental ways that we actually do better at modeling Earth. And then I mentioned things like nuclear winter and studying there's something called the anti-greenhouse effect, which was first really studied in reference to Titan, Saturn's moon Titan, which turns out to be relevant to certain aspects of the physics of climate on Earth. So there are these direct ways in which we get smarter about modeling climate on Earth by considering these alternate atmospheres and different situations, but applications of the same laws of physics, where hopefully the same climate models should work if we tweak them. And then when they don't work, we learn something about the models. So that's one way. But then in terms of the communication side of things, I've found that it's very valuable to have that different perspective, and especially in some situations where people maybe are not totally receptive to a climate message. You sort of come into the conversation from a surprising angle or an oblique angle, and somebody who's maybe enthusiastic about space exploration but doesn't think that they're that interested or concerned about climate change or doesn't trust what they've heard about it. I've had some sort of aha moments in conversation with people where you're talking about other planets, and then you start talking about Earth, but you're kind of coming into the conversation from a different set of assumptions. And I've found that can really help. It's that whole thing of finding common ground for difficult conversations. And there may be somebody who shares your interest in space exploration or is generally receptive to cool science, but is not really on board with your concern about Earth climate. And once you've found that point of common ground and that point of empathy, you can sort of ease into the more difficult conversation. And I found that having a sort of interplanetary perspective on climate has helped in that kind of situation too. And I always, whenever I teach about planetary science or astrobiology, I find that it's very natural to bring terrestrial climate change and concern about the future into the classroom, and not in any kind of a contrived way. It's really part of the same story. Here are planets, and here's what makes their climates. Here are the different physical variables, and here's physical variables that are changing about our planet, and here's the concern. And it's sort of a seamless transition. So I always try to, I don't even try, it just sort of is a natural part of the teaching I do, even if I'm talking about astrobiology or something of that nature, to bring it to the present moment on Earth and talk about how I see the situation and how we need to be thinking about it. So I'll stop there, and I will popcorn to Gabriele.
I'll keep it brief. On the first part, I think on how I've used my physics and astronomy background in my work, I think I'll give a few examples of the types of careers I was thinking of pivoting to. So as I mentioned, I have an instrumentation and experimentation background. So one thing I was really seriously considering was moving into systems engineering, but working on some sort of space-based Earth observation satellite. And I figured I can just apply the skills, I've been working on, testing and developing detectors in labs. So I can do that, but just for down-looking satellites rather than outward-looking. And that way we can kind of tie in the Earth stuff and hopefully maybe help the climate models. That was kind of my logical sequence of thoughts. Another thing I considered seriously was policy. And I think a lot of the skills that I would have used if I had gone into policy are similar to those that I'm using now in my foundation role. And this is kind of learning how to learn. Like as scientists, we have to learn a lot of different things and we have to do it quickly. And this is a super valuable skill. So like in my current job, and I think in policy, this would have been the same, you're learning about a lot of different topics. You're having to communicate these topics to various audiences. And we do this as scientists all the time. So those are just a few examples of the skills that you kind of develop as a scientist that are easily applicable. And then the second part about like doing the work, I think the best answer I can give is not my own, but there's a scientist and policy expert named Ayanna Elizabeth Johnson, who's like a personal hero. I don't know her personally, but she's kind of one of my heroes. And she has talked about this idea of this Venn diagram of to kind of figure out what your place is in the climate and in the fight against the climate crisis. And it's figuring out like the intersecting area of like your joy, like what brings you joy, what gets you out of bed in the morning, your skills, like what are you good at, what have you learned how to do, what are you kind of naturally good at, and then the actual work that needs to get done. So if you kind of think deeply about all these things and find something that's kind of in the intersection of all of them, like that's where I think your effort should be. Like I can't tell any one particular person, like this is the right answer for somebody with an astronomy or physics background. Like it really depends on your personality and interests. I will pass it to Nora.
I mean, I think that like I definitely have been steeped in the teaching world my entire career, and I will just put a plug that if you're interested in high school physics teaching, like there's ways to bring in environmental and justice and climate change into the physics or environmental science classroom, and there's like a real need for good physics teachers. As someone who's been on a lot of hiring committees, there's a real need, and there's fellowships that will pay for your graduate work and pay you to become physics and math teachers. There's a fellowship called the Noyce Fellowship that like paid for my grad school. And I think that there's like this, I think a lot about, so that's my plug. But I think a lot about how I talk about my students about making it so that my students who really want to go into science and engineering, realize that there are choices that are inherently being made in those jobs and that they're not absolved from those choices. I think that like a lot of times I have a lot of students who want to go into engineering, and are they really thinking about what companies they would be working for if they went into different types of engineering and the work they will be doing? And that as scientists often, we think of ourselves as immune from these choices, that we're just like doing the science, but what are the effects of those things? And I try to try to talk about that. And I think talking about environmental justice really brings that. Like we've been talking about a substation that's being built in East Boston, which is near the Logan Airport, if you've ever flown into Boston, where many of my students live, and what are the choices about where it's being built, like next to a playground in a floodplain, in a neighborhood, where people are living, and what are those choices that scientists are making, and how do they impact our climate? And so that's where I come from, and I'll pass it to Colin.
Yeah, so I think what I can contribute here is my experience of looking for jobs where I can apply my skills that I've built in astrophysics and to climate-related applications. And in general, like during my research, I was doing lots of programming, lots of data manipulation, different types of modeling, things like that. And a lot of these techniques you learn are directly applicable to many of the same problems. It's just called a different name. If you're coming from like data science background or something, you call it some machine learning model, but in astrophysics, we just call it something else. So a lot of these skills are basically exactly the same and directly transferable. And so when I was looking for different opportunities, there's things to do with more like general climate risks, like that could be with insurance companies even, or there's things to do with more like everyday actions, like, so that's more related to weather and energy. And these are all inputs to like climate solutions, because you need to have good weather models so you know how much energy is on the electric grid, how you can plan to add renewables, things like that. So there's all these different little details, little parts that you can be involved with. But what I also realized was that the specific skills you need, as in the background context of like climate or weather modeling, for example, you don't really need that. As like the training you get as a scientist, plus the technical skills you develop when you're doing scientific research, you can just use those and you can learn the context from like on the job. So you don't like, a lot of the times in these, when you talk to companies and what they want, it's really the technical skills. Everything else you learn on the job. So I wouldn't worry. So if anyone's considering, changing the private sector, for example, I wouldn't worry about the specific topic. And if you have no knowledge in that, it doesn't really matter. I had no knowledge of weather forecasts and I did a job in that and it's fine. And I say some of the things are like literally directly, like it's the same thing. An example is if you're used to, for observational astrophysics, you work with detectors, you have to calibrate those, doing a bias correction on the CCD. You do exactly the same thing for a weather forecast, except it's a gridded model. And so it's like techniques like that you don't even think, they're just called different things. So yeah, that's kind of my, I think, biggest takeaway, that we have all these skills and are directly applicable, and don't worry too much about the specific application. Obviously pick something that you're interested in, but knowing that these sorts of skills are useful in many different contexts.
Awesome. We are rapidly approaching the bottom of the hour, and I want to try to tie in some of the questions that were asked in the chat and the Q&A with a question that is specific to our platform here at Astrobites. We are writing mostly with an audience expecting them to be undergraduates in astro or interested in astro. And so keeping that in mind, the question that I wanted to ask is if you have advice for current physics and astro students interested in climate work. But I also wanted to tie in some of the other questions because I know our audience today is a lot broader than just this undergraduate student audience we have at Astrobites. So there's one question that is answered in the chat about resources to learn about jobs that tie in this climate work, and then also thinking about transitioning from a more physics sort of career or whatever career you're starting with to something in climate work, and thinking about the instability that can cause during that transition. So just advice for students and people further in their careers, bringing this physics to climate work and making that sort of transition or tying them together. And I'll remind you to keep it relatively brief so we can get to everyone. So can we start with Nora this time? Thank you.
Yeah, I don't have much to, I feel like I've shared about going into the education field. And I really do think that if that is something that excites you, like, there are ways to bring it into physics teaching, there's ways to bring it into environmental science courses, and young people are wonderful, and they are really passionate about these issues, and really care and are like, really want to engage on these issues. I'll pass it to Kirsten.
Olivia, could you repeat the first part of the question about?
Yeah, Yeah, the first part is just advice for students in physics or astro that are interested in climate work, just any advice, but then opening that up to those later in their careers as well.
Thanks. Yeah. Yeah, I mean, I just want to echo what Gabriele already said about using that Venn diagram that Ayanna Elizabeth Johnson. There's actually another one that's advertised by Patagonia, like a public figure that you can follow, who's amazing. Just really don't underestimate the like power of what like gets you excited. So of course you want to maybe do something like interesting, or you know, I don't know, like if it's research oriented, great, it's research oriented, and that's where you're going to make the biggest impact. But if it's community focused, then great. You know, I think not underestimating where you're going to find joy in the work that you're doing, and in the intersection of work that needs done, is a really, really powerful tool. So yeah, just echoing that as I think some of the most important advice, but kind of later on, and I guess targeting other people who are trying to make career pivots, or maybe just find a career for the first time, right, going out of college. This is always going to be challenging, and you know, I'm so grateful for this particular opportunity. But I think if you can find you know, anything that's even tangential to what you're interested in, and ask questions and talk to people. I think somebody mentioned like being involved with the Astronomers for Earth group, you know, putting your feelers out there and making it really clear what you're interested in doing. Like using those networks, because ultimately I think the network of astronomers is at large, like just really, really fabulous. And there are plenty of people who want to try to help you. So it's always going to be challenging, right, to make a career pivot, but there are resources and there are ways of doing it. And in the meantime, you can find the ways in which like you live your life, and the activism that you engage in with your local community or on a broader scale is going to be really powerful. So I'll pass to Colin.
Sorry, I was answering a question. What is the question?
Yeah, advice to students in physics and astro wanting to get into climate work, but then expanding that also to those later in their careers wanting to transition.
Yeah, okay. Yeah, I think kind of, I don't want to echo too much what I said before, but like I've done this fairly recently to look into, at least in the, not just the private sector, but also with NGOs and other types of work, to see what are the, you know, applications that I could work on. Like I wasn't so interested in looking at climate science, because I knew that was like, for me, it was already known, like enough, it was known well enough that we need to kind of implement it right now. So I was looking at ways to, you know, have direct application at the source and address the issues. So I think there are so many opportunities in that, especially in the private sector, because things are driven by a business use case. And I mean, in practice, like in big industry cares about their bottom line. And so if you can influence that and impact that, that's where the change will be. So for example, in this work I just started, company I'm working with is working with the very large food producers, and they want to reduce their emissions. And so like I'm helping with that, like enable that, so they can change like farmers' practices at the source. And so suddenly you have this, it's a climate solution, but it's also driven by a business use case. So then you have this kind of, you know, that's the mechanism that drives it. So like this, I mean, this is not to say that private sector is the only way to go, no, but it's, I think it's interesting because there are so many opportunities, and you can find your niche of what you're interested in specifically. If that's like programming, like a pure software development, there are many positions in that, or the likes of data science, something like that. And even other skills that you pick up as a scientist, perhaps writing grants or proposals, things like that. Then you could be more involved with potentially policy making. But again, this is working with NGOs and working with big companies to implement these policies, at kind of the higher level. So it's yeah, I think it's a very vague answer. There are many options. I would recommend so there's a resource called Climate Base, which is fantastic, and also Work on Climate, which is a big Slack group. And there you can find, there are thousands of people who work in NGOs, government, private sector. Reach out to them directly, ask them what they do, ask them, what are the impacts of your work, to get a sense of what's interesting to you, because maybe policy isn't the best thing for you. Maybe you really want to, you're good at programming, so you should do that, and you can have a really big impact with that. So I would recommend those two resources mainly. Yeah.
I'll jump in. Just to reemphasize, I think a thread between Kirsten and Colin's answers is talking to people. And this is something that I have done a lot of, and I have found super useful. I see Sydney joined us. She is one of the people that I have talked to in my search for my unicorn career. People just tend to be so generous with their time, and it's just incredibly valuable to hear what everyday life is like in various careers. So the way I did that was I kind of had a few different like job titles that I thought I might be interested in. And then I sought out people that had those jobs, and I just talked to them and really tried to imagine myself, living that kind of life and feeling how I would feel doing that every day. So that would be my biggest piece of advice, is talking to people.
Actually, segueing from that, Sydney, could you just quickly introduce yourself and possibly take a minute to briefly answer the question of moving from astrophysical studentship to maybe later career changes, or getting into climate work as a transition?
Yeah, sure. Thanks. And apologies for being late. Just sort of double booked in the hour. So it's been a little bit of a crazy morning. Hi, everyone. My name is Sydney Chamberlin. I'm a project manager for climate and nature-based solutions with the Nature Conservancy based in California. And in case you haven't heard of the Nature Conservancy, we're a large global environmental nonprofit working to conserve the lands and waters that all life depends on. And my work focuses really specifically on California climate policy. So I'm kind of on this one little niche, and happy to say more about my role, with future questions. I think this is a really great question. And I think everyone here has said really wonderful things. There's not necessarily like any one right answer, any one approach. Talking to people, which is this common thread we've heard from the other panelists, is a big one. And I think, to me, one of the big pieces is learning about yourself. It's like thinking about what are the skills you like to use the most in your work. And for everyone, that's going to look a little bit different. But when you think about like, what is a career? What is a job? Well, it's really the set of skills you're going to use most often, right? And so anytime you're thinking about a transition away from academia, I think an important starting point is to ask yourself, well, what are the things I really want to spend my time doing during the day? And then, like everyone here said, reaching out to people and learning about their roles and what they do, and how that, just kind of seeing where those things align with the skills you're interested in. That's a really big one. And I think, just as like a last note, I don't want to say too much because I know we've been on this question for a while, but it's, don't limit yourself. And, I think I've talked to a lot of people who are thinking about leaving various parts of physics, academia, and want to work on climate. And they're like, oh no, I don't have a science background in this, or I haven't done this before. Well, as long as you have like a pretty good set of problem solving skills, a willingness to learn, a little bit of a humble attitude, you're going to be fine. And so I would just say, like, don't limit yourself at all. Like, find something that you feel passionate about, and then find people working in that space and connect to them. And I think, like Gabriele was just saying, like, people are often willing to talk about their work with you and will give you advice and figure out, how to help connect you. So anyway, thank you. It's great to be here.
And just wrapping up, David.
Yeah, well, so much has been said that I agree with. But climate change, the climate emergency is a society-wide problem. There isn't any realm you can go into with your career that isn't connected to it in some way. And not only that, it's going to be with us for our entire lifetimes. You know, there are urgent aspects to it that we need to try to act on, especially in the next decade. But it's not like, you know, it's going to be part of our whole lives. It's an aspect of the era we live in. And if you're a physics student, you know, physics can equip you really to do so much. If you want to go into scientific research, you know, you can go into a field that's directly applicable to solving climate problems, which is great. If you want to, you know, just become an extragalactic astronomer, you still there's still so much you can do using your you know, scientific authority, which is something that we have that people respond to. And as, you know, as a communicator about the climate situation and inflecting it into your teaching, whatever you're teaching about, or you may not go into scientific research, but it's still very powerful to have had that scientific education. You know, clearly this is a problem that is not up to scientists to solve. Science is necessary, but certainly not sufficient to solve the climate problem. But educated people who have scientific knowledge going into policy and politics and education and all these other and activism and all these other realms is really empowering. The last thing I'll say is that it's always good to work on your communication skills. When I was an undergraduate science major and when I was in grad school, I took writing classes. And, you know, writing is, you know, some of us feel more naturally gifted in it than others, but it really is a craft that you can work on and learn if you study it, as well as other kinds of communication. And whatever you do, if you're a scientist going into research, those communication skills will be valuable. But if you're just a citizen going out and using that background to try to help with this problem in whatever realm you're in, communication is part of it. And it is something that no matter how naturally gifted you are, you can really improve and learn on. So I would also urge, along with your scientific studies, to study writing and study other aspects of communication, and it will help no matter what you do.
Thank you all for your great answers. I think we've touched on a lot of the themes that I was going to ask about. So even though we got to half of my list of questions, I think we answered all of them. So great job, everyone. And I see the Q&A is happening, and thank you to the panelists for responding to those answers. Just for everyone, there's open questions and answered questions, but the answered questions continue to have other answers from the panelists. And since we're at the bottom of the hour now, 11:30 for me, that is how much time we had scheduled for the panel. But so if anyone needs to leave now, panelists or attendees, that is okay. But I'm going to keep the Zoom open since I know a lot of people are hoping to continue to engage with this panel, and feel free to type your answers to the Q&A questions, but I'm going to ask another question, sort of tying in these questions in the chat and the Q&A with one that I also had about, the question was about eco-anxiety. So especially in the context of media coverage of climate change and misinformation about climate change. And then also someone in the Q&A asked about the carbon footprint of astronomy and some of the staggering numbers we see there. And I know Astrobites, we have covered some of those Nature astronomy papers, and what started us off here at Astrobites Climate Change Committee is Suchi's post on her own experience with eco-anxiety as an astronomy student specifically. So I open it up. We don't all have to answer if you're busy typing in the Q&A, but if anyone has thoughts on facing these types of feelings, so your answers, you're welcome to go in either direction, thinking about communicating climate change and advice for that, especially as we are a science communication platform here at Astrobites, but then also thinking about facing these feelings of eco-anxiety. So I will open it up to the panel now.
Well, I can jump in and at least try to share my thoughts. The eco-anxiety piece that's really hard, right? Because it's really hard to avoid it. And especially if you follow the news like at all, right? It's all we're hearing all the time. And it can be pretty overwhelming as a feeling. And especially like working in the space, I do feel like I kind of alternate between days where I feel really good because I'm like, okay, I know it's a problem, but at least I know my work is like helping to try to move the needle. But then other days it's just like so much information. I mean, I think dealing with that is a lot of like thinking about your community, like having a good community of people around you, and community is loosely defined here. It's like whoever your community and your people are, but connecting ourselves with people is so important right now, especially like we live in this digital age. We're always like online, we're doing things connecting to people remotely, but being like with people in person, it really is important for our mental health and our mental well-being. And so that's sort of the first one that I would suggest. And then I think it's going to sound kind of, maybe this sounds jaded or cliche, but like mindfulness and really focusing on that. My company is actually really progressive this way, and I really appreciate it. We actually I went through like an 8 to 12 week long mindfulness class with a bunch of my colleagues. And we just sat, learned, we talked about how to meditate. We talked about how to be in the moment. We all downloaded an app and that really helps. It's actually really good for our mental health. I think we're living in this time with like these incredible challenges, and they're, thrown in your face all the time. And so the more you can like help your mental health and learn really solid skills to like cope with those feelings, the better we can be. So I know maybe that's not a very satisfying answer, but that's my thought. For the latter part about communicating it, that's also really hard. And that's a problem that's also been exacerbated by the rise of disinformation and the way that information is spread on social media. So it's hard. To me, the core of that, a big core of it, is just really effective science communication. And it goes back to whether you're talking about climate change, frankly, or two black holes colliding. The question is, can you take what you're doing, this really complex, maybe abstract, very science-based work, and describe it in a way that people can understand? When people can understand science more, I think that we help to increase their scientific literacy overall. And I think that can help kind of tackle this problem. But it is really only one aspect of the problem. I feel like there's what we can do as communicators, but there's also sort of cultural shift that we need to have. And that second part is harder, and I don't necessarily have a good answer. So maybe I'll stop talking and see if any of the other panelists have thoughts.
Well, something that's related to eco-anxiety, but not exactly the same, is the subject of doomism. Where people get very convinced that it's already too late. And that can be a very disempowering feeling. We've really wanted to communicate to people that there's this sense of urgency and that this is real and it's serious. And in some ways, maybe we've been too effective at that, because there's at least some subset of the population that we've so thoroughly convinced of that. And depending on what news sources they get, they're so focused on the doom that they're in danger of giving up. And I've heard from some young people who basically feel that way, that, well, we're all effed, and we're cooked, and it's done, it's over. And that's, it's really not true. There's this wide dispersion in the climate curves looking into the future. Nobody knows which one we're going to be on, but the difference between those curves is what we do. That's the major source of uncertainty in these scenarios, is human action. And if you look at human history, nobody's good at predicting the future, and things ultimately tend to be dominated by nonlinear shifts in attitudes and in breakthroughs. And so nobody really knows what the end of the century is going to look like, including in terms of climate. So we have to break this narrative that we know the future, and the future is awful, and while still maintaining a sense of urgency, and it's tricky, but I feel like, it's important to, in our communication, also remind people of that there are a lot of very positive trends happening at the same time as all these scary things. Of course, that, the price of renewable energies has gone down so much faster than even the most optimistic people predicted. And that's huge. And so not to like look through at the world through rose-covered glasses, but to remind ourselves and other people we communicate to that, like they say in the Terminator movie, Sarah Connor says, the future is unwritten. There is no fate but what we make, and we do have the power collectively to determine how bad or not bad this gets. And I think we just really need to remind ourselves and remind other people that, and fight against this, being so good at convincing people that it's a problem that everybody becomes convinced that it's an intractable problem, which it's a difficult problem, but there are also all kinds of solutions being worked on. So we have to kind of balance those outlooks.
Yeah, I want to echo what Sydney said about doing this with other people. I think that realizing that you're not alone and realizing there's other people who are thinking about it from the policy side and have been working on it for years, and not feeling like you have to reinvent the wheel, and whether or not it's getting involved with a group like the Sunrise Movement or other local groups. I know that I was fortunate enough to have my roommate be a climate organizer, and so when I started wanting to bring this into my classroom, I spent a year overhearing her Zoom calls while I was teaching at the same time, because that was, life last year. And so I already had a sense of what some of the local hearings were and some of the issues were in a way that I wouldn't have otherwise. But then there were some issues I really did not know. And, what are the state bills that are currently happening? What are the local issues that are not even in the state legislators, never mind the national legislature, but happening on very, local levels? And, I especially, how can we support and uplift voices of, groups of people of color who are, on the front lines of having the impact of this, and not just do it for them, but say what is actually supportive and how can you amplify those messages. And I find that when I was designing my unit for my students, I really wanted there to be examples of where people have fought back and won, and so that it was not just doom, but they wanted to put a biomass plant in Springfield, Massachusetts, which is like the asthma capital, and people spent 10 years fighting back and winning, and there's not a biomass plant there. So how can those stories be woven in to quell some of that eco-anxiety?
Two very quick things, just kind of building off of also what Sydney said. There are therapists out there who are also now trained in eco-anxiety. So, there's resources out there that can help people get connected to therapists. So that's one option. There's also training programs that I should say I learned about both of these things through Astronomers for Planet Earth. So again, going back to the community, joining a group like Astronomers for Planet Earth can be helpful to just kind of have a space to share thoughts and feelings about this, but also resources. So these are two things I learned from there. There was something called resilience training that somebody mentioned recently that kind of helps better equip you to deal with uncertainty, kind of with a ecological perspective. So, there's also kind of professional help out there that could be a good thing to get connected to.
Awesome. Well, I think we should wrap it up here. I want to just appreciate everyone for showing up, appreciate the panelists. This has been a really inspiring, exciting discussion, and there's so much activity in the chat and the Q&A. All of this information will be compiled on Astrobites, and a summary. We have some live tweeting going on Astrobites. There's going to be a summary posted later today. So all this information, all these resources that were mentioned today will be accessible later. And once again, thank you so much to our panelists. It's been really exciting for our first Earth Week at Astrobites. And we'll stay engaged with this. We'll stay engaged with you. And we'll see you next year for our second Earth Week at Astrobites.